All right, everyone. Hello, and welcome to the first screencast for Chapter 19. In Chapter 19, we're going to be switching from our look at microeconomics to macroeconomics. And the first part of this chapter is really designed to help us understand what the differences between the two of the fields of economics are. Macroeconomics tends to deal with economy-wide issues, whereas microeconomics, which again is what we've been doing up until this point in the semester, is usually individual level decisions, either by firms or by households. In macroeconomics, we're looking at usually an entire political jurisdiction, usually a country, sometimes a state within the United States or a region of a different country. Sometimes there are city-wide macroeconomic forecasts, regional macroeconomic measures and forecasts. But for the most part, we're going to be talking about country-level, aggregate-level measures of the well-being of the economy and how the economy behaves. Some of the things we look at in macroeconomics are things like inflation, unemployment, economic growth, whereas what we've been looking at up to this point with our macroeconomics has been how individual markets operate. The supply and demand diagram is a diagram of an individual market. It might be an entire economy's market, but it's usually for just one good or service. We also look at how firms make decisions in terms of what's the optimal profit maximizing amount of output. And in some levels of microeconomics, you also model individual consumer behavior that way. But we kind of leave that to the side here in this course. But in an intermediate micro theory course, you might look at how individuals make decisions. And in micro, we look at the implications for price and quantity. So how a shift in supply, a shift in demand, elasticity, things like that affect the price and quantity. On macro, in addition to inflation, unemployment, and economic growth, there are other variables we look at, but those are really the big three that we're going to concentrate on in this class. So why don't we go ahead and get our first measure that we're going to use for macroeconomics, and that is the GDP of usually, again, a country. GDP can be for any political jurisdiction. Again, it can be a city, it can be a state, it can be a region. But for the most part, we tend to think of it in terms of national level measure of accounting. So the gross domestic product. So the GDP is the total amount of everything produced within a specific economy. And we use this to analyze a lot of different things, but primarily we want to look at the growth rate of an economy. Is an economy growing, and how quickly is that economy growing? We can use GDP to compare different regions, different nations, and often it's used as a kind of the first cut benchmark at the well-being of an economy, GDP overall. One thing to note, and we're going to talk about this again toward the end of these screencasts, is that GDP doesn't capture everything about an economy. It certainly doesn't capture everything about the well-being of a society as a whole. But it specifically doesn't capture everything about how well an economy is doing. There are some things it just does not measure. And so when looking at how well an economy overall is doing, it's just one piece of the puzzle in terms of how we measure that sort of thing. So what is gross domestic product? Literally, it's the market value for all the final goods and services produced in a nation within a specific period of time. Usually yearly or quarterly is how GDP is usually measured, but you could have monthly GDP. You could have weekly GDP if all of that data was available to whatever bureaucratic organization is trying to calculate the GDP. But for the most part, we look at quarterly or yearly GDP for a particular nation. It's the sum of all the output from all economic activity within whatever economy it is that you're looking at. So if it's the United States, it would be GDP for the United States overall. One thing that can be a source of confusion is that GDP measures both output in the economy and it also measures the country's income. That's because GDP is looking at all final goods and services bought and sold. So when someone buys something, someone else is selling something. So GDP measures that both sides of that coin. So why is GDP useful? Well, we use it to estimate living standards across time and nations. So it's one way we can look at how an economy is performed over, say, 10 years or 20 years. Or even 100 years. What we try to do is come up with a number that it measures the same thing at all points in times, and so that number is in some way comparable. Of course, we do have to adjust the GDP in some ways to account for some of this, and we're going to talk about some of those things in this chapter. It's also one of the primary ways we measure economic growth. If GDP goes up, then we would usually say that particular economy has grown by whatever the percentage rate is. And we're going to get into those calculations in just a bit. You can also use GDP to determine whether an economy is experiencing a short-run expansion or a recession or a depression. And there's actually very technical definitions of those things that we're going to get into in later chapters. But for the most part, an expansion is when GDP is growing, a recession is when GDP is contracting overall, and a depression is a severe sustained contraction in the size of GDP overall. All right, so I've tried to throw a few of these practice what you know, little multiple choice quizzes that kind of match up with some of the quizzes you might be doing as practice. For exams and things like that. And so what is gross domestic product? What does it measure? Well, it measures the nation's income. Again, it's the overall economic output, but you can also think of it as the nation's overall income is another way to think of GDP. And one way, again, we use that is to measure different standards of living. Of course, it's not exactly usable as total GDP. Just add up all of the economic activity in the economy, and we can't really use that to compare different countries because, of course, different countries have very different sizes of population. So it wouldn't really make a lot of sense to compare a really small population country and a really large population country to compare their GDP because, I mean, it tells you something, but for the most part, it's just telling you one country has a whole lot more people and firms in it than the other. So one way that we account for that is we use per capita GDP. So we basically just take all of GDP and we divide it by the population of the country overall. And so that gives you a number that is a little bit more comparable across two different countries. It sort of gives you a measure, although, you know, average versus median, we could argue about that, which is the better statistical summary statistic to use, but for the most part it gives you a good first brush at the average living standard in a nation. So one way we can see that is in comparing, say, China to Germany. China has a very large GDP here, $9,240 billion is its total economic activity within China, and Germany has 3,730. So at first brush, you might think that China has a higher standard of living. Of course, if you didn't know anything about the real world and you were just looking at these numbers, you might think that. But then, of course, once we bring in population, China has a population that is much, much larger than Germany, 1.357 billion people. So when we divide GDP overall by the population to get per capita GDP, we can see that Germany has a much higher standard of living than does China, at least in these 2013 numbers here that I'm showing. So China has a per capita GDP of 6,807, whereas Germany has a per capita GDP of 46,269. Now notice this is an average, and so we are not looking at the distribution of the GDP throughout the country. Certainly not every person in Germany makes $46,000 or anything like that. Again, it's a first brush approach at looking at standard of living, this per capita GDP. To really get at all the details, we're going to have to dig down a little bit deeper. And we're going to touch on some of that throughout the rest of the semester here. All right, yep, and those are 2013 examples. So here we can look at different countries, the size just overall. Now this is not per capita in column 3 here. This is just the overall GDP. And so you can see the U.S. has 16,768 billion is the size of the GDP in the U.S. And then when you divide by our population, we get a per capita GDP of 1,042. So this list is ranked by the just raw GDP number. So you can kind of get a sense of how GDP per capita differs across countries. For the most part, especially for countries that have been developed countries for a while, say the last 30 or 40 years, it really follows that the bigger countries with bigger GDPs have higher per capita. But the recently developing and developed countries, like say China and India, still have a much lower per capita GDP, even though their overall GDP is much larger. But as those countries continue developing, then what we'll see is that these countries, because of their population, will quickly rise to the top of this, even if their per capita is not quite at where the U.S. is in, say, 10 to 20 years. Another thing to think about when we're measuring economic growth is how GDP changes over time. So this is per capita GDP in the U.S. And when we say real here, it means we're accounting for inflation. And I'm going to come back to that in a bit, and we're going to talk a lot about inflation actually through the remainder of the semester. But this is a real number. So we've tried to take out the effect of inflation when talking about this per capita GDP here. And you can see that in the U.S. it's gone up quite substantially since 1965 to 2015. And again, this is controlling for that rising price level, that things have overall gotten more expensive. So we've taken that out, and you can still see a pretty dramatic increase here in the per capita GDP. And when we talk about growth, what we want to know is what is the rate from year to year of the growth of GDP overall. Let me bring in a few more countries so we can just kind of see what this looks like. And for the most part, for many countries, we can see that real GDP per capita has been going up. And here we're using 1990 international dollars. So that's the base year that we've taken the inflation out of the equation, is we've used $1990 for this particular graph. And you can see for many countries, especially a country like Poland, which was once an Eastern Bloc country under the control in the influence of the Soviet Union, they've had a very substantial, since the fall of the Soviet Union, there was a drop in their GDP as they shifted from a command and control style system to a more market-based system. And you can really see how this has gone up considerably. Turkey has had a lot of economic reforms also over this time period, as well as Mexico has had a lot of reforms, most notably trade reforms with the United States. India also has, since they've modernized their economy, they've also seen a dramatic increase in their per capita GDP. But we also see some countries that just kind of stay flatlined here. Somalia, which for a large swath of this time didn't really have a functioning government. And then Nicaragua, which has gone, has had problems with civil war and civil strife, and also has had a more command and control style economic system, has not really seen the kind of hockey stick style growth in their GDP. Another thing that we use besides that we use GDP for, besides just growth rates, is thinking about something called the business cycle. All right, and the business cycle is really kind of this ebb and flow of the economy expands, and then sometimes it overshoots, and then there's a contraction. That's the business cycle. So it's this short-run fluctuation around a long-run trend. And so when we talk about the business cycle, we talk about expansion, which is from the bottom of a growth rate to the top of a growth rate. And then we talk about a contraction, which is from the top of that growth rate in the economy down to the trough. And it's probably easiest to see just on a kind of a sample graph. So here is what the short-run business cycle might look like. So you get, and this is time on the horizontal axis, real GDP here. Again, real meaning we've taken inflation or the rising price level out of the equation. And you can see that there tends to be these undulations in the growth of real GDP. It can shoot up really quickly, and then there can be kind of a contraction, and then it goes up again. But this is all hovering around. Oh, and let me just label these things. So this is what I meant by from peak to trough. That's a contraction. And then from the trough of this wave form here to the peak is an expansion. And it generally kind of hovers around what we would think of as the long run trend of GDP. And I can bring a similar graph back in of the United States. This isn't per capita, this is overall GDP, but again, it is real GDP, so it has taken that inflation measure out, and you can see that you get the long run increase, this long run growth rate. But if we were to zoom in here, you can see that there are some undulations here. And this is the areas marked in blue are official recessions as designated by the National Bureau of Economic Research. So these are the troughs. And again, on this zoomed out graph, it's really kind of hard to even see the undulations here, but that's what these, you can see it here a lot with the Great Recession from 2007 era here. You can see that kind of contraction here, but most of the time when we see these recessions, it almost looks like maybe just a flat line or maybe a slight dip into negative territory for those recessions. All right, so that's it for the introduction to micro versus macro and GDP. We're going to move on into digging into GDP a little more deeply and seeing exactly how it's calculated, what's included, what's not included, and things like that. All right, everyone, hello, and welcome to the second screencast for Chapter 19. We talked about GDP a good bit, but exactly how is GDP calculated? And that's going to be what we're going to focus on in this screencast. So GDP, we said it counts the market value of all of the final sales of goods and services. So why is it that we use the market value, the value of the item as it sells at market, as opposed to some other measure of the value of the good or service? Well, quantities would be a bad way of going about it because it doesn't really give us a whole lot of information. 12 billion bushels of corn versus 8 million cars, well, even though 12 billion bushels of corn is more in terms of quantity, corn is not more important to the U.S. economy than is cars, because the average bushel of corn, of course, costs way less than the average car. So just by using quantities, we might get a false sense of overall GDP, and we might get a false sense of how important different industries are within that measure of GDP overall. And you can see it here with just a quick calculation. Corn costs $5 a bushel, so times 12 billion is only $60 billion, whereas cars, 8 million vehicles, an average price of $30,000, $240 billion. It's a much bigger component of overall GDP than would be corn. And also, once we convert to dollars, we can, of course, add all of these things up to get a measure that is comparable in terms of its units. So GDP does include both goods and services. It does include things that aren't tangible goods like cars or bushels of corn. It includes food, clothing, cars, houses, and other tangible goods. Services are intangible things: healthcare, entertainment, advice, travel, banking. A lot of the things that we see in modern developed economies that actually occupy a whole lot of the economic activity. What I'm doing right now, when I'm a professor, when I do research, that's all a service for the most part. There is maybe a tangible paper or tangible slides or something like that if you print them out, but for the most part, I'm a part of the service economy, and I imagine a whole lot of you will also be a part of the service economy when you get done with your education. So the composition of industries and economy has really changed a lot over the last 50 years, especially in the United States. So if you look at services as a share of the U.S. economy, it's gone from just above 40% here in 1950 to almost 70% right in 2009, 2010, something like that. It's fallen off a little bit as some manufacturing has come back to the U.S. from being outsourced. Most of that automated manufacturing, but that mix, I don't expect this overall trend to change a whole lot over time. So in our definition of GDP, one of the things that was in there is that's the final value of the goods. So what do we mean exactly by that? Well, we have this idea in macroeconomics of intermediate goods versus final goods. Intermediate goods are goods that firms repackage or bundle with other goods to be sold at a later stage. So something like milk that's sold to a coffee shop, that's going to be put into the coffee, and it's not in and of itself a final good, like maybe a gallon of milk at the grocery store would be a final good. Tires that are sold to a car manufacturer is also another example of something that's an intermediate good. Now, when you go down to Discount Auto or Discount Tire and you buy tires for your car, that is a final good. But when a car manufacturer buys it and puts it on the cars that are sold off of their lots, then that's an intermediate good. So final goods are the goods that are sold to the final user or the final consumer. And to get an accurate GDP estimate and to avoid double counting, we don't want to double count the value of two goods. We only use final goods when we're calculating the GDP for a particular country, or again, state or city, but for the most part, we'll think of country. So intermediate goods are not the final goods, and so we're not going to include those in the calculation. So a computer chip that is put into an iPhone, a really old iPhone here, I need to update my artwork, is an intermediate good. It's not counted in GDP overall. So let's practice what we know. So why doesn't GDP count expenditures on intermediate goods? I'll give you a second. Is it A, to make GDP calculations easier? B, because intermediate goods are used by firms instead of consumers? To avoid double counting, or intermediate goods have no market value? And as we just said, it's to avoid the double counting of the value of the good as an intermediate good and then as a final good. We only count the value of goods in GDP when it's the final good. Now, that doesn't mean we wouldn't want to care about those values for all sorts of other important things in economics, but in terms of calculating GDP, we only use the final market value of the good when it's sold to the final end user of the good. And so here is an example of how that double counting might work if we didn't just count the final retail value. So each step, if we look at the price at each step along the way, we might get a value for, say, a phone of $338, but if it actually sells for $199, including the retail and then all of the other goods that go into that, we would be overcounting the value of that phone in GDP. We only want to count the final market value in terms of GDP. So another way that we avoid this double counting problem is that we only look at production in a particular period. So let's say, and again, this is a way to avoid that double counting problem. So let's say a new car is produced, sold in 2014, and then 2 years later the owner decides to sell it. Well, we're only going to count it once. We're only going to count, we're only going to count the value of the car when it's produced and sold in 2014. We're not going to count it again when the owner decides to sell the good later. So what are some of the different components of GDP overall? So we're going to break this all down. I know some of this might be a little hard to see, but we're going to zoom in a second. But overall, the Bureau of Economic Analysis is the government agency that tallies up GDP. And it's overall, it's output, which is Y, consumption, which is C, I is investment, G is government purchases, and NX is net exports. So Y equals C plus I plus G plus NX is kind of the fundamental equation of macroeconomics. And of the different components here, consumption makes up by far the largest component of these things. And we'll see that in just a second. So let's now go through and break down and define these different categories within consumption, investment, government purchases, and net exports. So consumption is broken into three parts, goods and then services, and then we break goods down further into two subcategories, durable goods and non-durable goods. So a durable good is a good that's consumed over a long period of time, a computer, a refrigerator, a machine that a firm is using over the course of, say, 2, 3, 5, 10 years to produce other goods. Those are all durable goods. A non-durable good is a good that's consumed over a short period of time. So raw materials, might be non-durable goods. A sandwich is a non-durable good. Things like that. And then, of course, we have the service economy, which, again, as we mentioned earlier, has become a increasingly larger and larger part of the U.S. economy. Okay, so what about this investment thing? Well, investment includes capital purchases, changes in business inventories. New residential housing is actually counted as investment, not as consumption. And one important thing to note here is that investment does not include purchases of stocks and bonds. Those are not included as part of investment. What about government purchases? Well, government purchases are spending by state, local, and federal government entities. So any kind of spending that a government agency does is the government part of y equals c plus I plus g plus nx. It's that component of overall GDP. So fiscal spending, you might hear it called that in terms of when people are talking about different policy changes that the government might engage in to reduce, say, fiscal spending. That's what they're talking about, government purchases. One thing that's not included here, though, are transfer payments from one part of the government to the other. That's not included. So again, that would lead us into the double counting sort of area if one government agency transferred money to another and we counted that somehow as economic activity. It's really just pushing dollars around. There's no real economic activity going on there. So lastly, in our y equals c plus I plus g plus nx is net exports. So this is exports, goods, the value of goods leaving the country minus imports goods coming into the country. So if imports are greater than exports, then that term is negative, and we call that a trade deficit. It's not the greatest term in the world, trade deficit, because it indicates somehow that one side is losing, whereas anytime there's voluntary exchange in trade, both sides are gaining from it. But in terms of accounting for economic activity of the country as a whole, we do net out the trade deficit. Again, I tell students all the time when I'm live lecturing that I have a huge trade deficit with Kroger. I go there all the time and I give them a bunch of money, and all they give me are the goods that I want and I take back to my house to consume, and so somehow that's a deficit. But again, when we're talking about the economic activity of a particular political jurisdiction, we do have to take that out because that economic activity, those goods were produced in a different economic jurisdiction. So if we're looking at two states, we would subtract out exports and imports from one state to another. If we're looking at two different countries, we net out the imports and exports from one country to another when we're trying to measure the economic activity of that particular country. But I think trade deficit is not the best term because it brings in these connotations that aren't really accurate. But anyways, and if exports are greater than imports, we call that again a trade surplus. Again, not probably the best term because it's not like a deficit in terms of deficit spending, that you don't have enough money to pay for something. And it's not a surplus like I have extra money on hand. It's really just in terms of the flows of the value of the goods and services across the countries. So net exports represents a small fraction of total GDP. You hear a lot of talk about the trade deficit and trade surpluses in other countries as being this really big deal, but it's actually a pretty small part of the overall economic activity in most countries, and especially in the U.S. So is it bad, though, to be in a trade deficit? No, not necessarily. More imports means more goods and services for the people in the country. So again, we do use GDP to measure economic activity of a particular jurisdiction, but it doesn't really capture everything because we're only talking about the value of the goods and services. So in some ways, this trade deficit can be a little bit misleading. But as long as we're all clear on what it exactly means, it's completely fine to use it this way because but what happens is the term often gets misused and people use it misleadingly, unfortunately. All right, so we talked about this earlier, the fact that we have to take inflation into account when we're talking about how GDP changes over time. $1 in 1950 is not the same as $1 in 2010, 2020. So we have to take into account that fact. So nominal GDP, that's what we call it when we're just looking at dollars in that particular year. So GDP in 2010 is in 2010 dollars. GDP in 2011 is in 2011 dollars. We haven't tried to pull out inflation. We haven't tried to account for the fact that price levels have risen. We've just really measured it in the dollars of that particular year. Whereas real GDP tries to pull out inflation so that the dollars are constant over time, so that we can compare a dollar in 1950 to a dollar in 2010 or something like that. And what's happening there, what accounts for the difference between nominal and real, is that the price level has been rising. And we use different indices to measure that price level increase, and there's a bunch of different ones, and we'll use the most common one in this class. But what we do is we create a price level, and it's an index to measure how the prices of goods and services in an economy have increased or decreased over time. And for the most part, we see inflation. We see an increase in the price level of things. You hear your grandparents or great-grandparents talk about how, they used to go to the store and they'd get a moon pie and an RC Cola for 25 cents. Well, that's 25 cents in that particular year. That doesn't necessarily mean it was that cheap compared to a quarter today, because the price levels of everything have risen mostly slowly over that time period. There were some periods of high inflation in the late 70s, but certainly since the mid-80s, we've had relatively low levels of inflation, and so those dollars haven't quite been devalued as quickly over that time period. And the thing that we use is something called a GDP deflator. And so what we basically do is we calculate how the price level has been changing, and then we pull that out. We deflate those GDP numbers, which have been inflated by those rising price levels overall. And so we're going to use that. There's a table in the book, and I'll provide you the information when you need it to deflate GDP. And we're going to do an example of that here in a second. So let's practice what we know. So how is real GDP different from nominal GDP? Well, it's A. Real GDP is adjusted for inflation, and nominal GDP is just measured in current prices. So nominal GDP is in 2010, again, is 2010 dollars. Nominal GDP 2011 is in 2011 dollars. For real GDP, we'll pick a baseline year. Earlier, we saw a chart that used 1990 as the baseline year. You can use really whatever year you want, and there are different software programs in Excel or R or whatever you might be using if you're doing empirical work to calculate a real dollar amount. But we can see what the difference between those two looks like here. So these are both the same number. So this is nominal GDP in each year. What was GDP in those year dollars? And this is if I use the GDP deflator to deflate those to, looks like we're going back to 2009 dollars. And so what we have here is a gap. And you can see how the longer the time period is, the more misleading nominal GDP can be in terms of comparing year-to-year levels of GDP. And what do we call that difference? Well, it's inflation, right? The difference between these two is the inflation per year. So here we can see that we have, and this is one of those tables that gives us the nominal GDP, and then we've calculated, or someone has calculated for us the GDP deflator. So if you're wanting to convert between years, and we're going to do some examples here in a second, you can use this GDP deflator to convert, say, 2007 dollars to 2008 dollars, or the growth. If I want to know the growth rate between 2007 and 2008. I want to account for the fact that the price level changed between those 2 years. So all of the difference between these two numbers is not real growth. Some of it was just the fact that inflation happened. And if we just state the nominal GDP growth rate, we would be overstating the level of growth if there is inflation. And you can see here, this increasing price level indicates that there is inflation each year. We don't ever see it going negative, which would indicate deflation, which we haven't really seen in the U.S. for quite some time. So how do we go about doing that in detail? Well, we remove current prices from the nominal GDP data. We divide nominal GDP by the contemporaneous price level. So we deflate GDP. That's why it's called the GDP deflator. So we're going to convert to constant base year in prices. And again, it depends on your particular question what year you use as the base. Some people will use the last year of the analysis. Some people will use the first year. This graph here was using 2009, the first year in the series, as the base year to deflate the data. It really just depends on your particular question. But we do convert to constant base year prices, and then we multiply by the base year price level. We multiply by the base year price level times 100. So let me just give you an example of the formula here. So real GDP is the nominal GDP divided by the price level times 100. And that price level is given to you here in this chart. It's also known as the GDP deflator. So let's do an example of what that looks like, just so we can have a concrete example. So we're going to find real GDP for 2014. And here I've put an abbreviated version of table 19.5. I've just pulled out that row for 2014, so we don't have all that extraneous information. So in 2014, the nominal GDP is $17,348 billion, and the GDP deflator is 109. That's the price level. So we're going to plug in those numbers into this equation right here. So this is what we're going to use to find the real GDP. So T is 2014, the time period, the year. And so the nominal price, the nominal GDP is that $17,348 billion divided by the GDP deflator, or the price level, of 109 times 100. So we get $15.9157 trillion is the GDP, real GDP for 2014. All right. And again, that's in 2009 prices. How do I know it's 2009? Well, let me show you. On our table here, you can see that 2009 has the 100. So that means if I go backwards, I multiply by something less than 100. If I go forward, I divide by something less than 100. If I go forward in time, I divide by something greater than 100 when using this formula here. So that's your base year. Whatever gets the 100 for the GDP deflator is your base year. So again, this calculation, GDP, nominal GDP in 2014 divided by the 2014 GDP deflator times 100 gives you 15.9157 trillion, and that is real GDP in 2009 prices. Anytime you say real GDP or real GDP growth, you usually will also state what is the base year for those particular dollars, so that another person who says, I got a different number for that, well, you might be using different baseline years, and if you convert to the same year, then you'll get the same growth rate or the same overall real GDP. So we can calculate growth rates of GDP using this simple, this is just a percent change formula really. There's nothing special about it. You do a value minus, so this is the second value minus the first value, or the value at time t minus the value at t minus 1. That's why I called it the first value. So this is the first value, this is the second value, divided by the first value times 100. That gives you a percent change. Now earlier in the semester, if we did elasticity, in the particular course you're viewing this for, I think probably for all of the courses you're viewing this for, we did elasticity. We did a different percent change formula. We used a midpoint instead of the original point. But this is just a different way of doing it, and this is the more typical way we'll do it in macro when calculating growth rates with things like GDP or the price level you'll see in a second. So here is that percent change formula. So let's use it in an example. Let's find nominal GDP growth in 2012. So this is nominal. So we're just going to take the raw values of GDP and calculate that percent change without doing the deflator at this point. All right. So we'll have GDP in 2012, again, the second value, minus GDP in 2011, which again is the first value or time period minus 1. So 2012 was the time period, the t, 2011 was t minus 1, divided by the GDP in 2011, multiply that by 100. So if we bring back our table for those two particular years, then we can see that we get 16.155. Again, we're converting here from billions of dollars to trillions of dollars in the formula here. Minus 15.518 divided by 15.518 times 100. So we get a nominal, again, not real, but a nominal growth rate of 4.1. We would still probably want to pull out the inflation. And you can do that in a couple of ways. You could deflate these first. You could put these in constant $2009 and then calculate this, or as we'll see later, you can deflate this directly. I kind of like deflating each of the numbers. I think you get results that are a little more consistent, but either way does work. So we can also use that to calculate the price level change. So the percent change in the price level. So you take the price level at time t minus the price level at t minus 1 divided by the price level at t minus 1 times 100. So the second price level minus the first price level divided by the first price level times 100. Again, let me show you a quick example using this table 19.5. I'm going to do from 2012 to 2013. So the price level in 2013 is my second value minus the price level in 2012 is my first value divided by the price level in 2012 times 100. So we get 107 minus 105 right here divided by 105 times 100. So the percent change in the price level in 2013 was 1.9%. So that's how you calculate those growth rates. All right, so that's it for some of the nitty-gritty on how we actually calculate GDP and what the different components are. And what we're going to move on to in the last screencast for this chapter is talking about, well, what are some of the shortcomings of this GDP measure? It only measures certain things. It doesn't measure everything. And so we want to make sure we put that on the table when we're using this as a measure of economic activity in an economy.